Now, welcome back again. It is Mr. Scam, the science guy. We are back again with paper two or paper one, question three, vertical projectile motion for the pre-trial of 2025 Mpumalanga. So, on question three, which is the displacement time graph represents the motion of a golf ball thrown, the underlying thrown is a keyword, thrown vertically upwards from the edge of a building and bounces a number of times on the ground. So, by this thrown, we mean that the initial velocity would be greater than 0 meters per second. Now, in this case, the direction it's upwards. Next. Ignore the effects of friction. So from here, the ball is thrown upwards from the edge of a building, which means that we have a building and the ball goes up and then comes back down. So once it reaches the ground, it bounces and then it bounces again. So this is the first bounce and this is the second bounce. Okay. So 3.1, define the term of free fall. So for definitions, refer to the exam guideline, but if free fall, it can be explained as the motion of an object whereby the only force acting on that object is the gravitational force only. Well, I used only two times. You actually have to use it once. I'm just not sure of the sentence structuring. English is not my home language, guys. So anyway, 3.2, write down the following based on the graph. Now, from this graph, here's the graph, the height of the building from where the ball was projected. If we look at this diagram here and the graph, we can see that this line clearly resembles the graph. So which means from 0 going downwards, that would be the height, the distance from the top of the building. So the top of the building is 50 meters above the ground. So we have 50 meters here. Then the acceleration of the ball at t is equals to 1.5 seconds. The acceleration here, this position, it's the maximum height, and at the maximum height we know that the velocity is equals to 0 meters per second because it is now changing in directions from moving upwards to moving downwards, but the acceleration it's still the same, it's still 9.8 meters per square seconds. So it's 9.8 meters per square seconds, and the direction of acceleration is always downwards. Now 3.2.3, the maximum height the ball reached after the first bounce. Now here we have to look at this diagram. Now, I said that this is the distance from the top of the building. So here this is 30 meters from the top, which means if the total is 50 meters, then the remaining from the ground and then for the maximum height reached, it is now 20 meters. Okay, so here 20 meters. All right, now 3.3, calculate 3.2.1, the maximum height above the ground the ball reached for the first time. Now for this one, you're looking for the maximum height, so we can use this part, and here it will be our initial and this position will be our final. So we can then say delta y is equals to vi, change in time, plus 1 over 2a, change in time squared. But now let us choose the positive direction. We can say that upwards is positive. If we choose up as positive, then our displacement would have to be negative because now at this position it is going down. Now let's calculate and see. Delta y is equals to 0, and the time taken to reach the initial position should be the same as the time taken to reach the maximum height from the initial, since acceleration is the same. So which means with here it is 1.5, and then plus 1 over 2. We said downwards is upwards is positive, so downwards is negative. So negative 9.8 times 1.5 squared. So this would be 0 plus, and then this would be negative 11.025 meters, or 0.3 meters. So which would mean that our displacement, or the ball, or the maximum height, is 11.025 meters from the top of the building, because here we are using the top of the building as the reference, but the question is asking us for the maximum height from the ground, oh sorry, the maximum height above the ground. So the maximum height, the maximum height will then be equal to the displacement plus the height of the building. So the displacement being 11.025 plus 50 meters. So maximum height is now 61.03 meters from the ground. Now, question, the 3.3.2, the numerical value of T1, of time T1. So here we are given this time. Now we can calculate the time taken from here to the ground, or that's the only way we can do it. So here to calculate the time taken from the maximum height to the ground, we can use the same formula, delta y is equal to vi change in time plus 1 over 2a change in time squared. So delta y now, remember downwards is negative, so delta y it's negative 61.03. Negative 61.03 is equal to the initial, which is 0, times change in time, which is our unknown, plus 1 over 2 times negative 9.8 times change in time squared. So negative 61.03 is equal to, here it would be 0 plus 1 over 2 times 9.8, that would be equal to 4.9. So here it's negative 4.9 change in time squared. Then divide by negative 4.9 on both sides. So here it would then be 61.03 divided by 4.9. Here it will be 12.45510, so on, is equal to change in time squared. So change in time then be the square root of this. So the square root of this is then now 3.5291 seconds. But this is the time taken from the maximum height to T1. The value of T1 is equal to 1.5 plus 3.5291. So this plus 3.5291, this plus 1.5, that would give us T1 as 5.03 seconds. So this is the value of t. Alright guys, I'll see you again next time.